Hi, welcome to DSR's pharmacy class. Our topic is barbiturates under sedatives, hypnotics for the second year B.Pharmacy second semester students in the subject Medicinal Chemistry-1. Sedatives. These drugs decrease the activity of the CNS. That is, they reduce the excitability of the neurons. They produce calmness in the nerves. So pharmacologically, this condition is called sedation. This is useful in the treatment of anxiety. So sedatives are the drugs by depressing the CNS, reduce the excitement and produce calmness in the nerves and are used to relieve anxiety. Hypnotics. These drugs decrease the CNS and produce the hypnosis and are used in the treatment of insomnia. So hypnotics are the drugs by depressing the CNS produce hypnosis, that is sleep, which resembles the natural sleep, and are used to treat insomnia. So insomnia is the sleepless condition. So both sedation and hypnosis are the dose-dependent actions of the same drugs. When the drug is given in small doses, in low dose, it produces sedation. The same drug, when given in higher doses, it produces hypnosis. So same drug acts as a sedative and hypnotic. Examples of sedatives and hypnotics are barbiturates, benzodiazepines, amides, carbamates, and aldehydes. In this, our topic is barbiturates. Barbiturates. Basically, all these drugs containing the barbituric acid. Barbituric acid is hexahydropyrimidine 2,4,6 trione. This is a hexahydropyrimidine at this 2, 4 and 6 positions. Trione is there. This is derived from the pyrimidine. So 6-member 2 nitrogen containing heterocyclic ring. Barbital. To the barbituric acid at 5th position, 2 hydrogens are substituted by the ethyl groups. That is 5,5-diethyl barbituric acid is the barbital. Phenobarbital. Barbituric acid containing ethyl group and phenyl group at 5th position. That is 5-ethyl 5-phenyl barbituric acid is called phenobarbital. Mephobarbital. To the barbituric acid at 5th position, ethyl and phenyl groups are present, and at N1 position, methyl group is there. So methyl phenyl, that is mephobarbital. Emobarbital. In this special functional group is isopentyl structure. At 5th position of the barbituric acid, one ethyl and one isopentyl functional groups are there. Next, butobarbital. Ethyl and butyl structures are there at 5th position. This is 5-ethyl 5-butyl barbituric acid is the butobarbital. Pentobarbital. To the barbituric acid at 5th position, ethyl and pentyl structures are there. This is called pentobarbital. And secobarbital. To the barbituric acid at 5th position, vinyl group is there and pentyl is there. So this structure is called secobarbital. All the barbiturates are given in the same sheet. You can take screenshot of this sheet and practice. Mechanism of action of barbiturates. These drugs increase the activity of GABA at the GABA receptor. So GABA receptor is present in the chloride channel of the neuron. In the nerve membrane, this is a chloride channel, this is a GABA receptor. Upon action of GABA at the GABA receptor, it opens and allows the chloride ions into the neuron and increase the negativity up to minus 65 to 70 milliwatts. Barbiturates act at the allosteric site, that is not at the GABA receptor, another site, and makes the changes in the conformation of the GABA receptor. That makes the increase time of interaction of the GABA at the GABA receptor, and this makes the chloride ion channel keep open for the longer period. So more chloride ions influxes into the neuron, and this causes the excess negativity up to the minus 90 milliwatts. That is called hyperpolarization. So barbiturates act at the allosteric site to the GABA receptor on chloride channel of nerve membrane, increase the time of interaction of GABA at the GABA receptor, and thus increase the chloride ion channel for more time. Excess chloride ion influx causes the hyperpolarization. This prevents the generation of the action potential in the neuron. Thus, CNS depress and produce sedation and hypnosis. Barbiturates are used to relieve the anxiety, to treat the insomnia, that is lack of sleep condition, and are used to treat seizures, epilepsy. It is used as an anticonvulsant, and even it is used before surgery to relieve anxiety. Synthesis of barbital. Generally, urea condensed with the malic acid, it gives the barbituric acid. Here in the malic acid, hydroxy group and hydrogen are removed as a water molecule. These two water molecules are removed, and urea molecule condensed with the malonic acid and forms a cyclic structure, that is barbituric acid. Here to the barbituric acid at fifth position, two ethyl groups are required. For that, we are taking substituted barbituric acid, that is 2-ethyl, and here the diethyl malonate, which is derived from the malonic acid. It is further substituted at the second carbon by removing these two hydrogens, that is by substituting these two hydrogens with the ethyl structures. It forms a 2,2-diethyl malonic acid. So that is diethyl, this is for these two ethyls, and 2,2-diethyl, this 2,2-diethyl for these two diethyl groups, and basic malonic acid, malonic ester. Finally, it forms a 2,2-diethyl malonate. So urea molecule, urea is condensed with the diethyl 2,2-diethyl malonate. It forms a barbital. So this condensation is carried out in the presence of alcohol and sodium metal. Here, from the urea, from these two nitrogens, two hydrogens are removed, and these two hydrogens are attached to this ethoxide and forms the ethanol. This hydrogen interacts with this ethanol and form ethyl oxide and form ethanol. Again, this hydrogen interact with this ethyl oxide and form ethanol. Two molecules of ethanol is exit from the reaction, and these carbons join with the nitrogens and form this carbon form the bond with the nitrogen. Here also this carbon form bond with this nitrogen. Here this is a bond. Here cyclization reaction takes place, cyclic barbituric acid derivative of diethyl structure. This is barbital. When it is treated with the sodium hydroxide, it gives the salt of the sodium. So one of the oxygen is interact with the sodium and form the sodium salt. Generally, the oxygen between the two nitrogen carbon is interact with the sodium and form the sodium salt. Here, this double bond shift to this between the nitrogen and carbon. So this is the sodium salt of barbituric acid, barbital. So this is sodium barbital or barbital sodium. SAR of barbiturates. Generally, to act on the CNS, to act at the barbiturates receptor, barbituric acid is sufficient, but only this nucleus cannot reach the brain because of the ionization reaction or other chemical reactions which immediately metabolize the barbituric acid. By substitution here at the fifth position with the alkyl groups or aryl groups, it forms a stable compound. Again, this barbituric acid part of the molecule provide the polarity, that is provide the water solubility, and these alkyl groups provide the lipid solubility. Water solubility helps in the solubility in the water and absorption in the stomach and intestine, and distribution in the body in aqueous media. And this lipid solubility provided by these alkyl groups helps in the passage through the biological membranes and also passage at the blood-brain barrier. Again, for the optimal blood-brain barrier activity or optimal lipid solubility, 5 to 6 carbons totally at these two functional groups, total carbons required is 5 to 6 for the optimal activity. If the carbons decrease, the lipid solubility will be decreased, blood-brain barrier ability will be decreased. If carbon size increases, again it also decreases the activity because of the rapid exit from the body. And again at the fifth position, branched cyclic unsaturated groups presence make the drug shorter duration of action. Again at 1 and 3 positions, hydrogens are substituted by the methyl groups or alkyl groups and make the drug decreased duration of action. So second position, oxygen substituted by the sulfur and also it decreases the duration of action. Here we covered definitions, sedatives and hypnotics, barbiturates, chemical structures, mechanism of action, uses, synthesis of barbital, SAR of barbiturates. Thank you.